Okay, so let's go through the answers to workshop 9.2. If you need more help with explanation of this, I'm going to go through this a little bit faster than the lesson, so go watch the lesson for if you kind of are confused about what's going on here, go watch that video. But I'm going to go over the answers to this. I suggest you pause the video here and make sure that you can answer these, and then start the video and see if you can agree with the walkthrough I got here. So let's do this right now. So we're going to do workshop 9.2, and the first question, 1A, is if we have this formula here, the question is we have 2.1 or 2.10 grams of hydrogen, so 2.10 grams of hydrogen, and I want to know how many grams of ammonia will be produced. So how many grams of ammonia are going to be produced? Boy, it's focusing in and out like crazy. So let's set this up here. 2.10 grams of hydrogen. We're going to convert grams of hydrogen into moles of hydrogen using the molar mass of hydrogen. And on the periodic table, it says that the molar mass of hydrogen is 1.009 or 008. So we're going to say 1.008 times 2, because there's 2 hydrogens in the formula for hydrogen. So there's 2 hydrogens in the formula. So we're going to say there are 2.016 grams of hydrogen for 1 mole of hydrogen. And now I can say the molar relationship is a 3:2 ratio. For every 3 moles of hydrogen, there are 2 moles of ammonia. And now we're going to convert out of moles of ammonia into grams of ammonia, and we're going to do the same thing that we did with the hydrogen, except this time for ammonia we're going to add up a nitrogen, which is 14.007 plus 3 hydrogens. And I'm not on scientific mode, so I can't put a parentheses around there. So 1.008 plus 1.008 plus 1.008, 3 hydrogens, and that's our molar mass for ammonia, which is 17.031 grams of ammonia for every 1 mole of ammonia. So what we've done here is we have now converted grams of hydrogen have turned into moles of hydrogen, which turns into moles of ammonia, which then turned into grams of ammonia. So let's plug all this into our calculator and see what we get here. 2.1 divided by 2.016 times 2 divided by 3 times 17.013. And I've got 11.8, and with 3 significant figures, that's our answer. With 3 significant figures, we're going to put 11.8 grams of ammonia. Okay, that's the first one. So I'm editing the video. Some of my students were looking at it, a lot of students actually, and found a mistake in my solution to 1B. I said what I meant to say, but I inverted some values, and I got the wrong answer. So I'm very, very honestly extremely proud of so many of my students that caught that. That means that you're watching the videos, you're paying attention to the videos, and you actually understood what went wrong. So you guys are awesome. So let me write it right for you guys. Okay, so for 1B, we are looking at this problem here, and we know the amount of molecules of ammonia. We're going to convert it into grams of hydrogen. So to set this up, I'm going to talk about a road plan. I'm going to go from molecules to moles of ammonia, and that's NH3. And then I'm going to go to moles of hydrogen through stoichiometry, which then I convert to grams of hydrogen, and then I have to convert to kilograms of hydrogen. So I have to do 1, 2, 3, 4 different conversions here. And I'm going to use dimensional analysis to set this whole thing up, and then we'll put it in the calculator and solve it. So let's do that right now. We have 4.23 times 10 to the 27th molecules of ammonia, and using Avogadro's number, I can say that for every 1 mole of ammonia, we have 6.022 times 10 to the 23rd molecules of ammonia. So that took up a whole lot of room just for this little idea here. Molecules of ammonia cancel with molecules of ammonia, and you're in moles of ammonia. Then we're going to take that answer. Let's just do that right now. So let's plug this into the calculator. This calculator enters things a lot different than most scientific calculators. I've got to put this 27 exponent first, times 4.23 divided by 23 exponent divided by 6.022 equals. So at this point here, I have 7,024.24 moles of ammonia. So I'm in moles of ammonia. I got out of molecules, I'm in moles of ammonia. And I know from my balanced equation, and if you take a look here, the balanced equation, that the relationship from ammonia to hydrogen, it's a 2 to 3 ratio. So for every, this is where I messed up in the last video, 2 moles of ammonia, there are 3 moles of hydrogen. And you can see that again. For every 2 moles of ammonia, there are 3 moles of hydrogen. So we're going to take that number that we have right now, we're going to multiply it by 3 and then divide it by 2. And so now I've got this 10,536.37 moles of hydrogen. Moles of ammonia canceled out over here. Now we're in moles of hydrogen. And so road math, got that canceled out. Now let's convert hydrogen into grams. For every 1 mole of H2, we have 1.00 times 2, because there's 2 hydrogens. We have 2.016 grams of hydrogen. So we'll take this number, multiply it by 2.016, and now I've got moles of hydrogen canceled out with moles of hydrogen. I have now 4, oh that is not, I made a mistake again, but at least I caught this one. 10,536.37 times 2.016. There we go. That's better. 21241.32 grams of H2, because we just converted grams to H2. So what we did here, we took moles of H2, now we're in grams. And the last thing is I got to convert this into kilograms. So let's take this number and we'll multiply it. For every 1,000 grams, there's 1 kilogram. Oops, I don't need to, that didn't get canceled out. These guys get canceled out. So let's take this number and divide it by 1,000. And now we have our answer, which is 21.2 kilograms of hydrogen. And that's how you do it. So we went molecules to moles, moles to moles, moles of ammonia into moles of hydrogen into grams of hydrogen, and then grams of hydrogen into kilograms of hydrogen. So I got 21.2 kilograms of hydrogen. Hope you guys understood. Save your questions till the next time I see you. I look forward to it. Take care.